Okay, question 23. Rewrite each equation in exponential form. We want to remember that logs and exponents are inverse functions. When we look at a log function, we have this smaller number that's the base. And when we read log and this little 10, it reads as log base 10 of 1 over 10,000 equals negative 4. What this means is 10 to what power gives us the argument 1 over 10,000. And the answer is negative 4. So in exponential form, that would be 10 to the negative 4 equals 1 over 10,000. Now in class we talked about a little rule called the Roman numeral 9 rule, that where we drop the base down, kind of makes a little ix, 10 to the negative 4 equals 1 over 10,000. Okay, letter B. So now we can't, logic it out. 6 raised to what power gives us 216? The answer we're given is x, so it's 6 to the x equals 216. Here we don't see a base. If we don't see a base, our base is 10, so it's going to be 10 raised to x equals 5. And over here we see no base, but it's ln, and ln is just log base e. So e raised to what power gives us 7? Well, the answer is m, so it's e to the m equals 7. Number 24 is asking us to go the opposite way, to rewrite into log form. Well, now we have 32 raised to the 4/5 equals 16. So we're going to have log base 32 of 16 equals 4/5, because if I raise 32 to the 4/5, I would get 16. Letter B, my base is e. So instead of writing log base e, we're going to write ln. So we're going to have ln of 2 equals 3x. Now letter C you can write two ways. You can write log base 10 of 100,000 equals 5. Or you can just write log of 100,000 equals 5. Because if we don't see a base, we know that that's our common log, base 10. Number 25, evaluate each log expression. All three of these can be done without a calculator. I'm going to show you how to do them without a calculator, and then I'll show you real quick how to type them in. 3 raised to what power gives you 81? Well, 3 times 3 times 3 times 3 is 81, so the answer is 4. Letter B, 23 to what power gives us 1? Well, anything raised to the 0 power gives you 1. And here, again, no base means we have base 10. 10 raised to what power gives you 100? Well, the answer is 2. If you get stuck and you have a problem that you're not so sure about what power would give you the answer, you can use your calculator. Let me show you. Okay, so here we have, for example, in letter A, we have log base 3 of 81. What we can do is we can rewrite log base 3 of 81 using our change of base formula, which would be log base 10, no number, of 81 divided by log base 10, no number, of 3. And I'm going to use my calculator. Oh, there it is. And I'm going to type in log of 81, close my parentheses, divided by log of 3. And I get 4. And you can do that anytime you need to evaluate a log when you are allowed to use your calculator. Great. 26. Simplify each expression using the inverse relationship between logarithms and exponents. Well, what we're going to do is we're going to take a look at A an interesting way, and then that's going to give us the answer to all the others. For letter A, I have 11 raised to log base 11 of x. Well, we don't know what that is, so I'm just going to write equals question mark. And now what I'm going to do is I'm going to rewrite this exponent. Remember, this is an exponent right here. So let me highlight this for you. This is an exponent. So we're going to make the exponent, this exponential, into a log. So remember, the highlight, don't pretend it's a log, pretend it's an exponent. We have log base 11, the base comes down, the other two switch, of question mark, equals our exponent. And as soon as you write that down, you realize, aha, question mark, x, same thing. The answer is x. And same thing here, 3 raised to, well, not the same thing here. This one you can think 3 raised to what power gives you 3 to the x? The answer is just x. Here, e raised to what power gives you e to the x? It's just x. D is just like a, because you have e raised to log base e of x. This is the same thing you had here with the 11s, and it's just x. All right, number 27. The graph below illustrates a relationship between the functions y equals 7 to the x and log base 7 of x. What is the relationship between the two functions? The relationship between these two functions is that they are inverse functions. That's it. Explain how the relationship can be determined from the graph. Well, there are a couple ways it can be determined from the graph. The first way is that the graphs reflect over the line y equals x. One way you can do that is you can look at the graph and you can say, okay, I have a point, for example, here at 1, 0. When I look at the other graph, if I flip that point, I have a point at 0, 1. Okay, so here I've got one, looks like about 7, 1, and now I have a point at 1, 7. That's what makes them a reflection. So I guess you could say another reason, aside from just being specific and saying it's a reflection, you can say each point, inverse point is on the other graph. I don't like the way that sounds. Let's say each point on 7 to the x has an inverse point on log base 7 of x. That sounds better. Alright, the solving ones. 28a. Solve each equation. Your answer may be exact or correct to 2 decimal places. There are 2 different ways to do letter A. The first way is to find 2 to the 5th, and 2 to the 5th is 32, and say, okay, 4 raised to x equals 42, or 32, and then rewrite it as a log. And say log base 4 of 32 equals x. And then type that into your calculator. So we've got log of 32 divided by log of 4. And we get 2.5. That might be the easiest way to do it. We'll just stick with that. Letter B. Before we can do anything, before we rewrite it as a log, we need to isolate our exponent. Our exponential here is 5 raised to x over 4. So we're going to divide both sides by 2. I'm going to continue down here. Letter B. So we're going to have 5 raised to x over 4 equals a 125. Now we're going to rewrite this as a logarithm, and we have log base 5 of 125 equals x over 4. Now again, you can pick up your calculator if you want, but I happen to remember that 5 to the 3rd gives me 125, so I can go straight to 3 equals x over 4. If you need to pick up your calculator for that, then do that. I'm going to multiply both sides by 4, because it's x divided by 4, and I get x equals 12. Let's box, shall we? Alright, letter C. I have 10 to the x equals 40. There is nothing to do here but go straight to a logarithm. So, log base 10 of 40 equals x. Guess what? We do not know 10 to what power gives us 40. Letter C, we are going to have to go straight to our calculator. We can just say x equals log of 40 because 10 is the common base. So, oh, that's not good. Covering the problem. Log of 40. So to 3 decimal places. So right here, this is the exact answer. But if I went to 3 decimal places, that would be 1.602. so that's A through C. I'm going to clear the screen to work on, well, not yet. Soon I'm going to clear the screen. You might have to rewind. D is e to the x equals 9. There is nothing to do to isolate this. It's as isolated as it gets. So now we're just going to rewrite it, and it's going to be log base e, which is ln of 9 equals x. Now again, I don't know e to what power, so ln of 9 is, to 3 decimal places, 2.197. Letter E, again, nothing I can do there, but I'm not going to have enough room, I can already tell. So I'll work on it down here. Switch to red. So I'm going to rewrite it. Letter E is going to become, that comes down, log base 5 of 625 equals 2x. I'm pretty sure that 5 to the 4th is 625. I'm just going to double check that. Yep. Again, you can use change of base, log 625 divided by log of 5. So I have 4 equals 2x, and obviously divide by 2, and we're going to get x equals 2. Letter F says ln of x equals 3. Well, there's really nothing to do there except rewrite it. But now, instead of like a to e, these were all exponentials, and we rewrote them all as logs. Well, f to j, they're all logarithms. Therefore, they're going to get rewritten as exponentials. When you rewrite, you should be in the inverse format. One of the mistakes a lot of people made throughout the unit was that they would rewrite a log as another log, or they would rewrite the exponent as another exponent. That's just silly. We have log base e of x equals 3. Therefore, I'm going to run out of room. Letter F, I'm going to drop down the e, and e to the 3rd equals x. I grab my handy-dandy calculator, and e to the 3rd is 20.086. Alright, I'm out of room. I need to clear my screen. Alright, letter J requires exactly 0 work. Log base 2 of 8 is just 3. If you don't remember that, that's great. You can type it in your calculator, but really 2 to what power gives you 8? 3. Letter H, we need to first isolate the logarithm. And the way we're going to do that is we are going to divide both sides by 3. So now, we have log base 2 of x equals 5. We're going to rewrite that as an exponential, so the 2 comes down, 5 comes across, equals x, and we get x equals 32 for letter H. Letter I, nothing to isolate here, it's just a straight log. So we're going to get x squared equals 64. Now, normally when we would take a square root to solve like this, we would have to remember a plus or minus. However, we don't use negative bases. So this time only, we do not need a plus or minus. It's just x equals 8. Letter J, there's no isolating we need to do here. We're just going to rewrite. Remember, if I'm going too fast, you can always pause the video. Isn't that awesome? 4 squared is 16. Subtract 9. And you get x equals 7.